Deep in the heart of the ancient jungle, beneath a sky ablaze with stars, Mayan priests gathered atop towering pyramids, their eyes fixed on the heavens. They charted the movements of celestial bodies with uncanny precision, recording cycles that stretched across centuries. These weren't just astronomers, they were seekers of cosmic truths, weaving stories of creation that echoed through their sacred texts. But what if their myths held more than just allegory? What if, hidden within their lore, lay a startling glimpse into the fabric of reality itself? A whisper about the elusive Higgs Boson particle, the so-called God particle of modern physics. It sounds like something ripped from the pages of science fiction, yet the parallels are too striking to ignore. The Mayans spoke of a primordial force they called akin, a whirlwind of energy that shaped the universe from chaos, a concept eerily reminiscent of the Higgs field, the invisible energy web that gives particles their mass. Their cosmology described a dance of creation and destruction, where nothing could exist without this unseen power. Fast forward to 2012, when scientists at CERN announced the discovery of the Higgs boson, confirming a theory decades in the making. But here's the twist. Could the Mayans have hinted at this same idea over 1,000 years earlier? This isn't just about connecting dots across time. It's about reimagining how ancient wisdom might have tapped into universal truths long before microscopes or particle colliders. How did a civilization without advanced technology describe something so fundamental to existence? And what does that mean for our understanding of both history and science? As we peel back the layers of Mayan mythology, we'll uncover startling clues, sacred texts, astronomical alignments, and symbolic rituals that seem to point toward a knowledge far ahead of its time. So settle in, because this journey will take us from the shadowed temples of the past to the cutting-edge labs of today, where science and myth collide in ways you'd never expect. The question isn't just what the Mayans knew, it's how much more they might have understood about the universe than we've ever realized. The Mayans didn't just observe the stars, they spoke their language. Unlike other ancient cultures that saw celestial bodies as distant lights, the Maya believed the cosmos was alive, pulsing with energy that bound everything together. Their long count calendar, stretching over 5,000 years, wasn't just a tool for tracking time. It was a map of cosmic cycles, predicting eclipses and planetary alignations with jaw-dropping accuracy. Imagine a civilization so attuned to the universe's rhythm that they could calculate Venus's orbit with an error margin of just 2 hours per 500 years. That's like hitting a bullseye blindfolded from a mile away, but their genius didn't stop there. In the Dresden Codex, one of the few surviving Mayan texts, priests recorded tables tracing the movements of Mars and Mercury, alongside rituals tied to these celestial events. To the Maya, the heavens weren't just a spectacle, they were a living, breathing force. Their creation myth, the Popol, describes the universe as a dynamic web where gods, humans, and even particles of matter emerged from a single, swirling energy they called the heart of sky. Sound familiar? Modern physics describes the Higgs field in eerily similar terms, an invisible ocean of energy that permeates everything, giving substance to the formless. What's truly mind-bending is how the Maya visualized this interconnectedness. Their art and architecture are riddled with serpent motifs, not as mere decoration, but as symbols of cosmic energy in motion. Temples like El Castillo at Chichen Itza were designed so that during equinoxes, sunlight would slither down the steps like a celestial serpent, merging earth and sky. This wasn't just theater. It was a ritual echoing their belief that the universe thrived on dynamic exchange, much like the Higgs field's role in particle interactions. Even their concept of zero, a revolutionary mathematical leap, hints at their grasp of emptiness as potential. While Europeans dismissed zero as heresy, the Maya saw it as the womb of creation, a void humming with unseen possibility. It's no stretch to draw a line between their zero and modern quantum theories, vacuum energy. where particles flicker in and out of existence. For a civilization without telescopes or microscopes, their intuition about the universe's hidden architecture feels almost prophetic. So how did they do it? Some argue it was centuries of meticulous observation, passed down through generations of priest astronomers. Others suggest their rituals involving hallucinogenic plants allowed them to perceive dimensions beyond the visible. Whatever the method, one thing's clear: the Maya didn't just study the cosmos, they communed with it, and in their myths, their math, and their monuments, they left behind a tantalizing question. Were they merely poets of the stars, or did they glimpse truths we're only now beginning to unravel? The Popol isn't just a creation myth, it's a cosmic blueprint. At its heart lies the tale of the hero twins, Hunahpu and Xbalanque, who descend into Xibalba, the Mayan underworld, a realm not of fire and brimstone but of illusions, tests, and shifting realities. Their journey reads less like a simple hero's quest and more like a metaphor for energy's dance through the fabric of existence. Every trial they face, from deadly ball games to houses of darkness, bats and knives, echoes the way particles collide, transform, and emerge reborn in modern physics. Take the twins' resurrection, for example. After being burned and ground into dust, they rise again, first as fish, then as humans. This cyclical destruction and renewal mirrors the Higgs Boson's behavior. Particles annihilate and recombine within the Higgs field, their mass and identity fluid until stabilized. The Maya even described the underworld as a place where nothing stood still, a chilling parallel to quantum foam where particles flicker unpredictably at the smallest scales. Even the twins' final victory, outwitting the lords of Xibalba by disguising themselves as performers, then resurrecting the dead, hints at the duality central to particle physics. Just as light can be both wave and particle, the twins embody transformation itself, slipping between states like energy-shifting forms. Their story culminates with their ascent into the sky as the sun and moon, eternal symbols of cosmic balance. Modern science describes the universe as a dynamic equilibrium of forces. The Maya, millennia earlier, encoded the same idea in myth. The Popol's layers go deeper still. Before the twins, their father, Hunahpu, is sacrificed in Xibalba, his head hung in a calabash tree, which then bears fruit. When a goddess approaches, the head spits into her hand, conceiving the twins. This bizarre imagery evokes particle decay and recombination, a parent particle breaking down, its energy spawning new entities. The calabash tree itself mirrors the Higgs field's role, a silent, invisible framework that gives form to chaos. What's striking is how the Maya embedded these concepts in narrative rather than equations. Where physicists use matrices and detectors, the Kayich storytellers wielded metaphor, ball games as particle collisions, underworld gods as forces of nature, resurrection as energy conservation. It's as if they distilled the universe's laws into allegory, a poetic premonition of truths we'd only quantify centuries later. The question lingers: did the Maya intend these parallels, or are we projecting modern science onto ancient symbols? Perhaps the answer lies in between. Their shamans, after all, sought to experience cosmic truths through ritual and vision, not just observe them. In the flickering torchlight of Xibalba's caves or the silent depths of CERN tunnels, the same mysteries whisper across time. The feathered serpent Kukulkan wasn't just another deity in the Mayan pantheon, he was the living embodiment of motion itself. With the sinuous body of a snake and the vibrant plumes of a quetzal bird, this god symbolized the perfect marriage of opposites, earth and sky, matter and energy, the seen and unseen. But look closer, and Kukulkan's imagery reveals something astonishing. The serpent's coils, endlessly undulating across temple walls and sacred texts, mimic the Higgs field's invisible ripples, the very fabric that gives particles their mass. Just as Kukulkan slithers through both water and air, the Higgs field permeates every corner of existence, silent yet omnipresent. Now consider the feathers. Each quetzal plume, iridescent and delicate, could be seen as a metaphor for particles briefly flickering into being before vanishing back into the cosmic tapestry. The Maya depicted Kukulkan's feathers in meticulous detail, often arranged in intricate patterns that resembled particle trails in a cloud chamber, those fleeting moments when the invisible becomes visible. Even the serpent's dual nature, bound to the earth yet capable of flight, mirrors the Higgs boson's own paradox, a particle so massive it's nearly impossible to detect, yet so fundamental it holds the universe together. The parallels grow even more striking when you examine Kukulkan's role in Mayan rituals. During the equinox at Chichen Itza, shadows cascade down El Castillo's steps, creating the illusion of a serpent slithering toward the earth. This wasn't just spectacle, it was a ceremonial reenactment of cosmic energy in motion. Modern physicists describe the Higgs field as a dance of excitation and stabilization, where particles gain mass by interacting with the field. The Maya, it seems, visualized this dance through Kukulkan's descent, divine energy made manifest, rippling through time and space. But here's where it gets truly mesmerizing. Kukulkan wasn't just a force of creation, he was also a teacher, credited with bringing knowledge, astronomy, and even the calendar to humanity. In one legend, he descends from the stars, bearing secrets of the cosmos. Replace stars with particle colliders and secrets with scientific breakthroughs, and the story echoes the Higgs boson's own revelation, a hidden truth pulled from the void by human curiosity. Perhaps the most profound clue lies in Kukulkan's name itself. In Yucatec Maya, Kukulkan breaks down to feathered and serpent, but linguists note the root Kayuk also implies something sacred, resplendent, a shimmering, almost unstable brilliance. That's uncannily close to how physicists describe the Higgs boson, a fleeting, high-energy event, dazzling in its significance but vanishing almost before it can be observed. Whether by intuition or insight, the Maya may have encapsulated one of physics' greatest mysteries in a single, poetic symbol. So was Kukulkan merely a mythic allegory, or did the Maya glimpse a deeper truth about the universe's scaffolding? The answer might lie in the way both ancient priests and modern scientists seek to explain the inexplicable, through stories of forces unseen, energies that shape reality, and serpents that slither not just through temples but through the very fabric of existence. Standing at the base of a Mayan pyramid, you'd be forgiven for thinking you're staring at a staircase to the gods. But what if these towering structures were something far more sophisticated? The pyramids at Tikal, Palenque, and Chichen Itza weren't just tombs or altars. Their precise alignments with solstices, equinoxes, and even Venus's rising suggest they functioned as cosmic antennas, channeling celestial energy. Modern particle accelerators like CERN Large Hadron Collider are designed to smash particles together at unimaginable speeds, revealing the universe's building blocks. The Maya, lacking metal or electricity, may have built their own version in stone, a symbolic collider where rituals, architecture, and astronomy converge to tap into the same fundamental forces. Take the Pyramid of Kukulkan at Chichen Itza. Its 4 sides each have 91 steps, totaling 364 when combined with the shared platform at the top, 1 step for each day of the solar year. But the genius lies in the angles. During equinoxes, sunlight strikes the northern staircase just so, casting a serpentine shadow that slithers down to meet a stone serpent's head at the base. This isn't just artistry, it's a meticulously engineered phenomenon that transforms light into motion, much like how particle detectors convert invisible energy into observable data. The pyramid's 9 terraced levels mirror the 9 underworlds of Mayan cosmology, echoing the layered dimensions physicists theorize in string theory. Were these steps merely symbolic, or did they encode a deeper understanding of reality's layers? Now, compare the pyramid step design to a modern COLLIDERS Chinese letter structure. Both are circular or quadrilinear, both guide energy along controlled paths, and both seek to reveal hidden truths. The Hadron Collider's tunnels bend particle beams into collisions, while Mayan pyramids funneled light, sound, and human movement into rituals meant to commune with the divine. At Kukulkan, acoustic studies reveal that clapping at the base of the Temple of the Inscriptions produces an echo resembling the call of the sacred Quetzal bird, a deliberate sonic resonance, as if the structure itself were tuned to cosmic frequencies. Physics tells us vibration underpins all matter. The Maya may have ritualized this principle millennia ago. Even the materials whisper secrets. The pyramid's limestone blocks contain high quartz content, a mineral known to generate piezoelectric effects, small electrical charges when under pressure. Could the Maya have sensed this energy, interpreting it as divine force? Their rituals often involved bloodletting atop these temples, where drops of royal blood were thought to nourish the gods. In a bizarre twist, modern particle detectors use liquid argon or scintillators to track energy substances that, like blood, light up when interacting with invisible forces. The parallels are unsettling. Both cultures sought to make the intangible tangible, whether through stone or silicon. Perhaps the most compelling clue lies in the pyramid's celestial alignments. The Temple of the Cross at Palink's three main structures form a perfect alignment with the setting sun on the winter solstice, a day the Maya associated with the underworld's opening. Similarly, particle physicists speak of portal-like events, tiny ruptures in spacetime where exotic particles might briefly emerge. The Maya didn't have the vocabulary of quantum mechanics, but their architecture suggests an intuitive grasp of thresholds between realms. When a shaman stood atop these temples during solstices, surrounded by chanting and incense, were they attempting to bridge worlds, much like scientists do today with beams of protons? This isn't about claiming the Maya had particle physics textbooks. It's about recognizing how awe of the cosmos drives both ancient and modern seekers to similar conclusions, even when separated by centuries. Their temples weren't crude imitations of colliders. They were expressions of the same human yearning to touch the invisible threads weaving reality together. Whether through equations etched in chalk or hieroglyphs carved in stone, the message resonates. The universe speaks in patterns, and sometimes the oldest voices understand them best. For the Maya, the towering Ceiba tree wasn't just a plant. It was the spine of the cosmos. Its roots plunged deep into Xibalba, the watery underworld. Its trunk anchored the earthly realm, and its branches stretched into the heavens, cradling the stars. This sacred axis connected all layers of existence, a living bridge between worlds. But peel back the metaphor, and the Ceiba's structure mirrors something startlingly modern. The Higgs field, that invisible scaffold scientists say gives the universe its substance. Just as the tree's roots and branches touch every plane of reality, the Higgs field permeates all space, from the densest star to the void between atoms. Think of the Ceiba's fruits, those spiky pods bursting with silken fibers, as particles gaining mass. In Mayan lore, these fruits nourished gods and humans alike. Much like the Higgs field, feeds particles their mass through interaction. When an electron moves through the Higgs field, it's like a seed passing through the Ceiba's branches. The encounter transforms it, giving it weight and form. The Maya even depicted their gods perched in the tree's canopy, weaving destinies, eerily reminiscent of how the Higgs mechanism shapes the behavior of matter itself. The parallels grow richer when you examine the Ceiba's role in rituals. Shamans performed ceremonies beneath its branches, believing it channeled divine energy, a concept that aligns with how physicists describe the Higgs field as a medium for transferring mass. The tree's sap, sticky and golden, could be seen as a metaphor for the field's stickiness, slowing particles down and granting them heft. And just as the Ceiba's roots drew nourishment from hidden depths, the Higgs field draws its power from the quantum vacuum, an unseen wellspring of potential. But here's where the analogy takes a breathtaking turn. The Maya believed the Ceiba's flowers housed the souls of ancestors, a notion that hauntingly parallels quantum entanglement, where particles remain mysteriously linked across distances. The tree's height, reaching hundreds of feet, symbolized a ladder to cosmic knowledge, not unlike how particle colliders aim to climb toward truths about the universe's origins. Even the Ceiba's resilience, thriving for centuries in harsh jungles, mirrors the Higgs field's constancy. It's believed to have activated a fraction of a second after the Big Bang and has persisted ever since, unwavering. So was the Ceiba merely a poetic symbol, or did the Maya intuit a truth science would later quantify? Perhaps the answer lies in the tree's very name. In some Mayan dialects, Ceiba derives from a word meaning to sustain or to uphold, a fitting label for the Higgs field, the silent force upholding reality itself. Whether through visionary ritual or sheer observational genius, the Maya may have grasped a profound secret. That existence, from the smallest particle to the grandest galaxy, is held together by invisible threads, roots and branches woven into the fabric of space. Among the intricate carvings on Mayan stelae and temple walls, certain glyphs stand out not for their grandeur, but for their uncanny resonance with modern physics. Take the symbol for wind or breath known as ik. At first glance, it's a simple curl like a gust frozen in stone. Yet this deceptively elegant glyph often appears in context describing creation, where gods summon life into being with a whisper. To the Maya, ik wasn't just air in motion. It was the invisible force animating all things, a precursor to the Greek pneuma or the Hindu prana. But what if this glyph held a double meaning? Modern physics describes the Higgs field as an omnipresent wind too, an energy current that imparts mass to particles as they move through it, like leaves caught in a breeze. The parallel is striking. Both traditions depict an unseen medium that gives form to the formless. Then there's the glyph for star, ek, often depicted as a blossom with 4 petals. While it clearly represents celestial bodies, the Maya associated stars with the souls of ancestors, eternal, luminous, and woven into the fabric of the cosmos. This echoes the behavior of fermions, the particles that make up matter, which gain mass by interacting with the Higgs field. In a way, the Maya may have visualized particles as star stuff, their glyph encoding a truth physicists would only articulate millennia later, that we're all quite literally made of rearranged stardust. Even more provocative is the glyph Chulul, symbolizing the soul or vital essence. Unlike Western depictions of souls as wispy ghosts, the Maya rendered it as a series of nested scrolls or spirals, a visual akin to quantum spin, the intrinsic angular momentum of particles. These scrolls often radiate outward, suggesting an energy field extending beyond the physical body. Compare that to the Higgs mechanism, where particles feel the field's influence as a kind of cosmic drag, shaping their behavior across space. The Maya may not have had equations to quantify this, but their glyphs hint at an intuitive grasp of forces that permeate and define existence. Perhaps the most tantalizing clue lies in the glyph Kayin, representing both sun and time. Its circular form, bisected by a cross, mirrors the Mayan concept of cyclical time, but it also resembles Feynman diagrams, the stick figure sketches physicists used to map particle interactions. In those diagrams, lines curve and intersect, tracing the dance of matter and energy. The Maya, too, saw time as a dynamic weave, where celestial events repeated in sacred rhythms. Could Kayin have been their way of encoding a universe where time, light, and matter are inextricably linked? The brilliance of these glyphs lies in their duality. They functioned as both practical language and metaphysical code, compressing layers of meaning into a single stroke. Where modern science relies on mathematical formalism, the Maya distilled cosmic truths into art, a reminder that knowledge can wear many faces. Whether by accident or insight, their symbols seem to brush against the same invisible fabric we're still unraveling today. The question isn't whether the Maya had a secret physics textbook. It's whether their glyphs, like ancient equations carved in stone, captured whispers of universal patterns that transcend time. The roar of the crowd echoed through the grand courts of Chichen Itza as players clad in padded armor lunged for a single, ominous object, a rubber ball heavier than a human head hurtling at deadly speeds. To the Maya, this wasn't just a sport, it was Pak Ta Pak, a ritual reenactment of the universe's most fundamental dance, creation through collision. The ball, carved from sacred rubber and infused with symbolic weight, became more than an object. It transformed into a cosmic metaphor. Every thunderous strike, every rebound off the court's sloped walls, mirrored the chaotic yet precise interactions of subatomic particles smashing together in modern accelerators. Picture the ball court itself, its towering walls forming a narrow alley open to the sky. These boundaries weren't arbitrary. They represented the invisible constraints of the Higgs field, the energy grid that dictates how particles move and interact. Just as the ball couldn't escape the court's physical limits, particles can't evade the Higgs field's influence. It's the silent referee of the quantum arena. When players launched the ball with their hips or forearms, they weren't just scoring points. They were reenacting the moment a proton, careening through the Higgs field, suddenly gains mass and slows, as if the cosmic court itself had absorbed its momentum. The game's brutal stakes deepened the metaphor. Victory wasn't just about skill, it was a matter of life and death, with some historians suggesting the losers or perhaps the winners, in a grim twist, faced ritual sacrifice. This echoes the fate of particles in high-energy collisions, annihilation. When the Higgs boson itself was discovered at CERN, it lasted less than a billionth of a second before decaying into other particles, a microscopic sacrifice that revealed the universe's hidden order. The Maya, too, saw destruction as a necessary step in renewal, their ball games culminating in bloodshed to feed the cosmic cycle, much like energy is never lost, only transformed. Even the ball's material whispered secrets. Made from latex harvested from sacred rubber trees, mixed with morning glory vine sap to enhance its bounce, it became a perfect symbol of elasticity and tension, qualities the Higgs field exhibits as it stretches and warps under particle interactions. The ball's unpredictable ricochets mirrored quantum uncertainty, where a particle's path can't be fully predicted, only probabilistically mapped. And just as scientists trace particle trails in cloud chambers, the Maya tracked the ball's path across the court's markers, reading its movements like diviners deciphering cosmic omens. The most haunting parallel lies in the court's architecture. Many ball courts featured stone rings mounted high on the walls, hoops through which players aimed to propel the ball. These rings, often carved with entwined serpents, symbolized portals between worlds. Much like the Higgs field creates conditions for particles to cross over from pure energy into tangible matter. Sending the ball through the ring wasn't just a feat of athleticism. It was a symbolic recreation of the universe's first moments when energy condensed into form. Modern physicists might call it symmetry breaking the instant the Higgs field switched on, allowing particles to acquire mass. The Maya enacted this pivotal transition in stone and sweat, their game a liturgical retelling of cosmic genesis. So was Pak Ta Pak merely a sacred sport, or did its rituals encode an intuition about reality's fabric? The answer might lie in the game's aftermath. After the final goal, after the sacrificial knife fell, the Maya believed the cosmos had been reaffirmed, its balance restored through human participation. Today, particle physicists chase a similar epiphany, that by recreating primordial collisions, we glimpse the universe's blueprints. Whether on the ball court's hallowed ground or in CERN's subterranean tunnel, the quest remains the same, to play the game of creation until it reveals its deepest rules. When a Mayan king or queen drew a stingray spine across their tongue, letting blood drip onto strips of bark paper, they weren't just performing a ritual, they were acting as conduits in a grand cosmic transaction. Bloodletting ceremonies depicted vividly in murals at Bonampak and Palenque were more than displays of piety. They mirrored the universe's most fundamental exchange. Just as particles gain mass by interacting with the Higgs field, sacrificing momentum to become tangible, the Maya believed royal blood spilled in sacred spaces released Ceiba, the life force that nourished the gods and sustained creation. This wasn't mere symbolism, it was a physics of the spirit where energy flowed between realms. The parallels are uncanny. In particle physics, mass isn't an inherent property. It's acquired when particles like quarks or electrons drag against the Higgs field, trading kinetic energy for substance. The Maya conceptualized a similar trade-off. Rulers, as intermediaries between worlds, offered their vitality, literally dripping blood onto bundles of paper burned as offerings to activate the gods' reciprocation. The smoke curling skyward wasn't just incense, it was a binding agent threading the human and divine like the Higgs field threads through the vacuum of space. Even the implements used obsidian blades, stingray spines hinted at precision. These weren't crude tools but carefully chosen instruments, much like the finely tuned detectors at CERN that capture fleeting particles. Consider the timing. Bloodletting rites often coincided with celestial events, eclipses, solstices, or Venus's rise moments when cosmic energies were believed to peak. The Maya saw these alignments as portals, akin to how physicists describe high-energy collisions as gateways to hidden dimensions. When Lady Zoc, the powerful queen of Yaxchilan, pulled a rope studded with thorns through her tongue during a lunar eclipse, she wasn't just enduring pain. She was synchronizing her sacrifice with the cosmos's rhythm, echoing how particles must collide at precise energies to reveal the Higgs boson. Both acts hinge on a shared principle. Transformation requires exact conditions and a release of stored potential. The aftermath of these rituals deepened the connection. After blood offerings, the Maya described renewed agricultural fertility, timely rains or military victories, tangible outcomes from intangible exchanges. Modern physics, too, speaks of the Higgs field's aftermath. Particles that were once massless, hurtling at light speed, suddenly slow and coalesce into atoms, stars, and life. The mechanism differs, but the underlying theme resonates. Existence thrives on reciprocity. Even the Maya's belief that royal blood carried unique potency finds a loose parallel in how certain particles, like top quarks, interact more strongly with the Higgs field, gaining disproportionate mass. Perhaps the most poignant link lies in the concept of debt. The Maya believed the gods had sacrificed themselves to create the world, and humans owed a perpetual blood debt to maintain cosmic balance. In physics, the Higgs mechanism is similarly framed as a cosmic bargain. Particles pay with energy to exist as matter. Without this exchange, the universe would remain a soup of weightless, chaotic energy, no stars, no planets, no life. The Maya's rituals, then, weren't just superstition. They were an intuitive grasp of equilibrium, a recognition that creation demands sacrifice. Whether through the sting of a spine or the flash of a particle collision, both traditions point to the same truth: nothing emerges from nothing. Everything has a cost, and energy, spiritual or quantum, is the currency. This isn't about equating blood with bosons. It's about recognizing how human beings across millennia and cultures have sought to explain the ineffable forces that shape reality. The Maya's bloodletting rites and CERN colliders share more than metaphor. They share a lineage of curiosity, a drive to reach beyond the visible and touch the scaffolding of existence. One used temples and twilight ceremonies, the other uses tunnels and terra-electron vaults, but both ask the same haunting question: what price must we pay to glimpse the machinery of the cosmos? And in that question, ancient priests and modern physicists stand shoulder to shoulder, united by wonder. Buried within the fragile pages of the Dresden Codex, a bark paper book that survived centuries of humidity and European purges, lies an astronomical masterpiece that defies its ancient origins. Among the vivid illustrations of gods and serpents, scribes painted meticulous tables tracking the movements of Venus with such accuracy that modern astronomers still marvel at their precision. But these weren't just calendars, they were equations etched in imagery, predicting eclipses down to the hour across cycles spanning decades. To achieve this, the Maya didn't merely observe the sky. They mapped its hidden rhythms, uncovering mathematical harmonies that resonate with the same universal laws physicists study today. What makes these eclipse tables astonishing isn't just their accuracy, it's how the Maya derived them. Without telescopes or written numerals, they calculated Venus's synodic period, the time it takes to return to the same position relative to the Sun, as 584 days, just 2 hours off modern measurements. They even accounted for the gradual shift in eclipse seasons, a subtlety many ancient cultures missed. This level of precision suggests something profound. The Maya didn't see the cosmos as chaotic or ruled by whimsical gods. Their charts reveal a conviction that the universe operated by consistent, calculable rules, a belief central to modern science. Dive deeper into the Codex's pages and the physics parallels grow sharper. One table outlines a cycle of 11,960 days, roughly 46 years, after which eclipses repeat in near-identical patterns. This isn't just observational data. It's evidence of the Maya grasping periodicity, the idea that celestial events recur in predictable intervals. Today, we know this regularity stems from gravitational dynamics. The Moon's orbit, Earth's tilt, and the Sun's pull all intertwine in a cosmic clockwork. The Maya may not have known Newton's laws, but their math hints at an intuition of invisible forces governing motion, much like the Higgs field governs mass. The Codex's imagery adds another layer. Beside the tables, deities pour water from jars or wield weapons, symbolizing the destructive power of eclipses. Yet these scenes aren't random. They align with specific eclipse phases, as if myth and math were fused. Compare this to how physicists personify forces, gluons holding quarks together, or the Higgs giving particles mass. Both traditions blend abstraction with narrative, using storytelling to tame the incomprehensible. But here's the clincher: the Maya didn't stop at recording eclipses. They corrected their tables for drift, inserting adjustment intervals akin to our leap years. This reveals a startling sophistication. They understood their models were approximations, requiring tweaks to stay true. It's a mindset echoing modern physics, where even the best theories like general relativity break down at quantum scales, demanding refinement. The Maya, it seems, were proto-scientists testing hypotheses against reality. Why does this matter? Because it reshapes how we view ancient knowledge. The Dresden Codex isn't a relic of superstition. It's a testament to humans' timeless drive to decode the universe's patterns. Whether through glyphs or graphene detectors, the quest remains the same: to uncover the rules woven into the fabric of reality. And sometimes the oldest voices articulate truths we're still learning to hear. To the ancient Maya, zero wasn't just a placeholder, it was a portal. While other civilizations feared emptiness, dismissing it as non-existence, the Maya revered it as potential itself. Their glyph for zero, a shell or an oval with curled ends, didn't signify absence but a fertile void, a space humming with unmanifested possibility. This radical concept mirrors one of modern physics' most mind-bending truths, that what we call nothing is anything but. The quantum vacuum, where the Higgs field operates, is a seething ocean of virtual particles flickering in and out of existence. Proof that emptiness is, paradoxically, the universe's most generative state. The Maya's zero first appeared in their long count calendar, a system so precise it could calculate dates millions of years into the past or future. But unlike later cultures that adopted zero purely for arithmetic, the Maya embedded it in their cosmology. Their creation myth describes a time before time, when only the void existed, a darkness pregnant with the gods' whispers. This aligns eerily with quantum field theory, where the vacuum isn't empty but brimming with fluctuating energy. Even in a total absence of matter, the Higgs field persists, an intangible scaffold waiting to impart mass to particles. The Maya's zero, then, wasn't just a mathematical tool. It was a metaphysical acknowledgement of the unseen forces that underpin reality. Consider how both systems treat nothingness as dynamic. In Mayan rituals, priests invoked zero as a transformative threshold, a moment between breaths, the pause before a storm. Similarly, the quantum vacuum is anything but static. Particles emerge spontaneously, borrowing energy from the vacuum before vanishing again, like echoes of the Maya's cyclical creation myths. Even the Higgs mechanism depends on this paradox. Particles gain mass by interacting with a field that arises from the vacuum's latent energy. The Maya might have phrased it poetically, the shell waiting to be filled, the silence before the song, but the underlying principle resonates across millennia. The parallels grow richer when you examine symbolism. The Mayan zero glyph, often shaped like a conch, evoked the womb of creation, a closed space hiding infinite potential. Compare that to physicists' depictions of the quantum vacuum as a foam, where space-time itself bubbles with virtual particles. Both images suggest a hidden architecture beneath apparent stillness. Even the Maya's use of zero in calendrics hints at this deeper layer. Dates weren't just points on a line, but nodes in a vibrating web of energy, much like quantum events unfolding in the Higgs field's invisible lattice. Perhaps the most profound connection lies in the power ascribed to nothingness. The Maya believed zero wasn't passive, it was a cosmic actor, the silent partner in all creation. Their astronomers used it to mark celestial transitions, moments when the universe seemed to reset. Modern physics reveals a similar truth. The Higgs field symmetry breaking, triggered in the vacuum, is what allowed particles to acquire mass after the Big Bang. In both worldviews, emptiness isn't the end, it's the beginning, the silent stage where existence steps into the light. So was the Mayan zero a fluke of numerology, or did it encode an intuition about reality's fabric? The answer might lie in how both traditions grapple with the unimaginable. Faced with the void, the Maya saw not oblivion but a canvas. Today, physicists peer into the quantum vacuum and find not emptiness but the seeds of all structure. Whether carved in stone or scribbled in equations, the message is the same. Nothing is everything, and zero is where the magic begins. The resurrection of the hero twins in the Popol isn't just a climactic moment of myth, it's a cosmic blueprint for how energy transforms into matter. After being crushed, burned, and scattered like dust in Xibalba's underworld, Hunahpu and Xbalanque don't simply return to life. They reconfigure, first emerging as fish gliding through unseen currents, then reforming as human shapes. This metamorphosis mirrors the Higgs mechanism with uncanny precision. Particles don't just appear with mass, they undergo a fundamental shift, emerging from the field's invisible currents like the twins rising from the watery abyss. The parallels don't stop there. Just as the twins outwit the lords of death by disguising their true nature, dancing between forms as performers, the Higgs boson itself is a master of disguise, decaying so rapidly into other particles that scientists can only infer its existence from the fragments left behind. The Popol's description of the underworld amplifies the metaphor. Xibalba isn't a static hell but a realm of illusions where corridors shift and tests unfold in layers. This mirrors the quantum vacuum where virtual particles flicker unpredictably, and the Higgs field stabilizes chaos into measurable reality. When the twins finally defeat the Dark Lords, they don't destroy them. They strip them of their power to deceive, reducing them to stone idols, a poetic parallel to how the Higgs mechanism tames wild, massless particles into the orderly atoms that build our world. Even their ascent as the sun and moon echoes physics' symmetry breaking. The moment the universe's primordial unity fractured into complementary forces, light and shadow, particle and wave. Dig deeper into the symbolism and the connections grow richer. Before their rebirth, the twins' father, Hunahpu, suffers a fate that seems bizarre until viewed through a particle physics lens. His decapitated head hangs in a calabash tree, spitting into the hand of a goddess to conceive his sons. This grotesque imagery aligns strikingly with particle decay. A parent particle Hunapu breaks apart, its energy birthing new entities, the twins, through a mediator, the tree, akin to the Higgs field. The calabash tree itself, hollow, vessel-like, becomes a perfect metaphor for the Higgs field's role, an invisible container that shapes energy into form. What makes this myth so electrifying isn't just its parallels to modern science, but its narrative embrace of duality. The twins don't reject the underworld, they master its rules, turning darkness into a tool. Similarly, the Higgs field doesn't eliminate chaos, it harnesses it. Without the frenetic energy of the quantum vacuum, the Higgs mechanism would have nothing to sculpt. The Maya understood this interplay intuitively, encoding it in a story where resurrection isn't a return but a transformation. When modern physicists speak of the Higgs boson as the God particle, they're echoing an ancient truth the hero twins embodied millennia ago. Creation isn't a single act but an endless dance between annihilation and renewal, where every ending carries the seed of what comes next. To the Maya, color was more than pigment, it was a language of cosmic order. Their sacred hues, red, white, black, and yellow, weren't just decorative. They mapped the cardinal directions, elemental forces, and the very fabric of existence. Red, tied to the east and the rising sun, symbolized birth and renewal, its fiery intensity echoing the energy of creation itself. White, linked to the north and the cool breath of the wind, embodied purification and the intangible, like mist curling over morning jungles. Black, facing west, represented the underworld's transformative darkness where decay seeded rebirth, and yellow, aligned with the south and the sun's zenith, pulsed with vitality, the golden thread stitching life together. These colors weren't static, they were dynamic forces shifting with ritual and season, much like the elusive flavors of quarks, those fundamental particles that dance at the heart of every atom. Take red, the color of blood and dawn. In Mayan rituals, red ochre adorned temples and kings, a testament to life's sacred pulse. Physicists might smile at the parallel. The up quark, which gives protons their positive charge, could be seen as the atomic equivalent of Mayan red, energetic, foundational, indispensable. White, the hue of bones and clouds, finds its counterpart in the strange quark, a particle that defies expectations, drifting through matter like a spectral whisper. Then there's black, the shade of obsidian and midnight, mirroring the charm quark's enigmatic heft, a dense, mysterious presence that bends the rules. And yellow, the radiance of corn and sunlight, aligns with the down quark, stable yet unassuming, the quiet anchor of atomic structures. The connections deepen when you examine how these colors and quarks interact. Mayan artists layered red and yellow to depict harvests, their interplay ensuring fertility. Similarly, up and down quarks bind to form protons and neutrons, their partnership building the nuclei of everything from stars to human cells. White and black, opposites in Mayan cosmology, find harmony in the quark world too. Strange and charm quarks, though rare, emerge in high-energy collisions, fleeting yet vital to the universe's balance. Even the Maya's fifth direction, the center, represented by green, the color of jade and sacred Ceiba trees, finds a loose parallel in quantum chromodynamics, where the gluon acts as the invisible glue holding quarks together. But here's where the metaphor ignites. The Maya didn't just assign colors to directions, they wove them into narratives of transformation. A priest wearing black during an eclipse ritual wasn't merely invoking darkness, he was channeling the underworld's generative power. Likewise, quarks don't just exist, they transform, flipping flavors during particle decays. A down quark becomes an up quark in radioactive decay, shifting identities like a shaman donning different ritual masks. Both systems reveal a universe in flux where stability is an illusion and change is the only constant. The brilliance of this color quark analogy lies in its refusal to be literal. The Maya didn't know about subatomic particles, and physicists don't consult the Dresden Codex. Yet both frameworks, separated by centuries, point to the same truth. Reality is a tapestry of interlocking forces, each with its own role, rhythm, and resonance. Whether through the vibrant murals of Bonampak or the flash of a particle detector, we're witness to the same cosmic dance, one where color and flavor aren't just properties, but portals to understanding the universe's deepest symmetries. To the Maya, time wasn't a straight path leading from past to future. It was a wheel turning ceaselessly like the gears of a cosmic clock. Their long count calendar didn't just measure days, it carved existence into grand cycles, each era ending and renewing like the phases of the moon. This wasn't mere poetry, it was a radical vision of reality where history repeated itself, where gods and mortals played out the same dramas across millennia. Modern physics, with its rigid timelines and cause and effect chains, seems worlds apart until you peer into the quantum realm, where particles defy linear time altogether. Imagine the Maya's great cycle, a span of 5,125 years culminating in cataclysm and rebirth. They saw this not as an endpoint but a pivot, a moment when the universe reset like a spinning coin settling back to its starting position. Now compare that to quantum mechanics' closed time-like curves, hypothetical loops where particles return to their own past. Theoretical frameworks like loop quantum gravity even suggest spacetime might be woven from tiny, self-repeating threads echoing the Maya's belief that time itself was cyclical at its core. Both systems, though separated by centuries, grapple with the same haunting question. Does the universe remember? The Popol offers a clue. When the hero twins defeat the lords of Xibalba, they don't erase the underworld, they transform it, ensuring its trials will repeat for future generations. This mirrors the behavior of quantum fields, where interactions leave imprints, virtual particles flickering in and out of existence, each collision rippling forward and backward through time. The Maya intuited that nothing truly disappears. Energy simply reshapes itself, spiraling through cycles of destruction and renewal. Even their rituals reinforced this ceremony's time to celestial recurrences, as if human actions could harmonize with the universe's eternal return. Yet the contrast with modern physics is stark. Einstein's spacetime is an arrow flying irreversibly from Big Bang to entropy, but delve deeper and cracks appear. Quantum entanglement defies locality, with particles influencing each other instantaneously across distances, as if time and space were illusions. The Higgs field itself is timeless, existing unchanged since the universe's first moments. Could the Maya have glimpsed this duality? Their calendars tracked both linear events, a king's reign, a dynasty's fall, and repeating patterns, Venus's dance, eclipse seasons, suggesting they saw time as layered, a river with an undying current beneath its surface ripples. The most tantalizing overlap lies in decay and regeneration. The Maya believed each cycle's end brought upheaval, floods, fires, skies darkened by ash before life re-emerged purified. Particle physics reveals a similar rhythm. Matter constantly annihilates and reforms. Protons decay, Higgs bosons vanish in a flash, yet their energy feeds new particles, a cosmic recycling program written into the laws of nature. The Maya's world ages might be mythic expressions of this truth that existence isn't a line, but a spiral, ascending through iterations of itself. So was their cyclical time mere myth or a prescient metaphor for quantum reality? Perhaps the answer lies in the way both systems confront the unthinkable. Faced with time's vastness, the Maya sought order in repetition. Today, physicists wrestle with time's fluidity at quantum scales. Both arrive at the same unsettling conclusion. The universe may not move forward so much as revolve, like a door on a hinge, swinging between states we're only beginning to comprehend. The jaguar moves through the jungle like a shadow, powerful, silent, its paws connecting with the earth in a rhythm older than time. To the Maya, this creature wasn't just an animal, it was a nagual, a spirit guide embodying primal force. Jaguars ruled the underworld in Mayan lore, their strength untouchable, their presence a reminder of nature's raw power. Strip away the myth, and you'll find an uncanny parallel to modern physics' weak nuclear force. The invisible hand that governs particle decay, a process both relentless and essential. Just as the jaguar's might shapes the forest, the weak force shapes atoms, allowing stars to burn and elements to transform. The connection isn't just poetic, it's profound. When a radioactive nucleus decays, spitting out an electron or neutrino, it's not so different from a jaguar bringing down prey, a controlled release of energy that sustains the larger system. Now shift your gaze skyward. The Maya revered birds, especially the quetzal, its iridescent feathers flashing like lightning as messengers between worlds. These creatures symbolized speed, agility, and the ability to traverse boundaries, much like the electromagnetic force that rockets photons across the universe at light speed. Birds carried prayers to the gods. Electromagnetic waves carry signals to our phones. Both are connectors, bridging gaps with invisible threads. The quetzal's flight, weaving through clouds, mirrors the way light bends around stars, guided by the same fundamental rules. Even the vivid colors of a bird's plumage find their counterpart in the electromagnetic spectrum, those radiant wavelengths that paint everything from sunsets to auroras. The Maya saw birds as divine intermediaries. Physics reveals them as unwitting avatars of a force that literally holds matter together. Then there's the serpent Kukulkan's coiled form, shedding its skin in an eternal cycle of death and rebirth. No creature captured the Mayan imagination like the snake, its very body a metaphor for transformation. This mirrors the strong nuclear force, the glue that binds quarks into protons and neutrons, resisting the universe's pull toward chaos. Just as a serpent's loops seem to defy gravity, the strong force defies expectation, growing stronger as particles pull apart. A cosmic tug-of-war that keeps atomic nuclei intact. The Maya depicted serpents as bridges between realms, their undulating bodies symbolizing energy in motion. Physics tells a similar story. Inside every atom, the strong force dances, its grip so relentless it can fuse hydrogen into helium, powering the sun itself. What's striking isn't just the parallels, it's the duality. The Maya didn't see these animal spirits as separate, they were intertwined, each playing a role in the cosmic balance. Jaguars, birds, and serpents appeared together in rituals, their energies harmonized. Modern physics reveals the same interdependence. The weak force enables solar fusion, the electromagnetic force transmits its light, and the strong force fuels the reactor. The universe, it seems, speaks in archetypes, whether through myth or mathematics. The brilliance of this analogy lies in its fluidity. The Maya didn't reduce forces to equations, they embodied them in stories, allowing each generation to feel the cosmos's pulse. Today, we quantify these truths with particle accelerators and quantum theories. Yet both traditions, ancient and modern, point to the same humbling realization. The universe is alive with invisible actors, each playing its part in the grand dance of existence. Whether you call them naguals or nuclear forces, their power remains unchanged. The only difference is the language we use to name them. The Maya didn't just pray to the wind, they spoke through it. When priests invoked Ik, the sacred breath of life, they weren't simply calling upon a gust or breeze. This force was far grander, an invisible current that animated gods, humans, and even the stars themselves. In their rituals, Ik flowed through ceremonial pipes, whistling like the cosmos exhaling, a sound believed to carry prayers to the heavens. Strip away the myth, and you're left with something astonishingly close to the Higgs field, an unseen, omnipresent energy that breathes substance into the formless. Think of Ik as the original cosmic wind. The Maya described it as the medium through which gods imparted life, whispering souls into clay figures in the Popol. Similarly, the Higgs field isn't just a passive backdrop. It actively endows particles with mass, shaping them from ethereal waves into tangible matter. Both concepts share a striking duality. They're intangible yet indispensable, silent yet sovereign. Without Ik, the Maya believed creation would collapse into silence. Without the Higgs field, particles would zip through the universe at light speed, never cohering into atoms, planets, or people. Even the rituals surrounding Ik hint at deeper physics. Shamans used conch shells as wind instruments, their spiral chambers mimicking the whirl of hurricanes, a nod to Ik as both creator and destroyer. This mirrors the Higgs field's own paradox. It stabilizes matter, yet its interactions require energy to tear particles from its grip. The conch's hollow interior, cradling the priest's breath, becomes a metaphor for the quantum vacuum, empty yet brimming with potential, a womb where energy condenses into form. The parallels sharpen when you examine Ik's role in healing. Mayan medicine attributed illness to blocked or imbalanced Ik, much like physicists trace particle behavior to their interactions, or lack thereof, with the Higgs field. A healer's chant wasn't just poetry, it was a tuning fork resonating with the body's unseen energies to restore flow. Modern science describes health in similar terms: molecular bonds, cellular communication, all governed by forces invisible to the naked eye. Perhaps the most poignant overlap lies in language itself. The glyph for Ik resembles a curl of smoke or a ripple in water, capturing motion's essence. Physicists, too, visualize the Higgs field as a sea of ripples, its excitations giving rise to particles. Both systems grasp that reality's fabric isn't static, it vibrates, hums, breathes. Whether through the whisper of a shaman's prayer or the hum of a particle detector, we're straining to hear the same cosmic rhythm, the pulse of a universe where emptiness is alive, and every atom sings with the memory of that first divine inhalation. For the Maya, jade wasn't just a stone, it was frozen time, carved into masks, beads, and even the teeth of kings. Its near-indestructible green brilliance symbolized eternal life, a material so enduring it outlasted dynasties. Gold, though rarer in their lands, held its own cosmic significance. The sweat of the sun god spilled onto the earth as molten radiance. These weren't just decorative luxuries, they were alchemical aspirations, embodiments of transformation. Jade's unyielding hardness mirrored the soul's resilience, while gold's luminosity captured the sun's divine fire. But hidden within their reverence for these materials lies a startling parallel to modern particle physics, specifically how the Higgs mechanism grants particles their defining properties, turning ethereal energy into tangible matter. Think of jade's journey from rough stone to polished artifact. Mayan craftsmen spent lifetimes grinding it with sand and reed drills, revealing a core that resisted decay. This painstaking process mirrors how particles like electrons or quarks acquire mass through the Higgs field. Before interacting with the field, they're like unshaped jade, pure potential, zipping through the universe weightless. But the moment they engage with that invisible energy web, they slow, condense, and gain identity, much like jade gaining luster under the artisan's hand. The Higgs field doesn't create mass, it reveals it, unlocking properties latent in the particle, just as carving reveals the stone's hidden brilliance. Gold, on the other hand, embodied a different kind of alchemy. The Maya associated it with Kainish Ahau, the sun god, believing its glow was celestial energy made solid. When nobles wore gold pectorals or ear spools, they weren't just displaying wealth, they were channeling solar power, anchoring the divine to their bodies. Here, the parallel to the Higgs mechanism becomes even more striking. Just as gold reflects light, giving it visible form, the Higgs field reflects onto particles, granting them mass by capturing their interaction with the universe's underlying energy. The Maya saw gold as congealed sunlight, physicists might describe mass as congealed Higgs interactions. Both transformations hinge on the same principle, raw energy taking on measurable material form. The rituals surrounding these materials deepen the connection. Jade was often placed in royal tombs, its durability ensuring the king's spirit would endure like the stone itself. Gold adorned rulers during solstice ceremonies, its sheen amplifying their connection to celestial forces. These practices echo how the Higgs field operates as a cosmic stabilizer. Without it, particles would remain fleeting, unable to coalesce into the atoms that build tombs, temples, or even the bodies of kings. The Mayas' jade and gold weren't just symbols of immortality, they were metaphors for the very processes that make existence possible. What's truly mesmerizing is how both systems, Mayan cosmology and particle physics, grapple with the same existential puzzle. How does the intangible become tangible? The Maya answered with ritual and artistry, turning stone and metal into vessels for the eternal. Physicists answer with equations and collisions, tracing mass to a field that hums beneath reality's surface. But the underlying truth remains unchanged. Transformation isn't magic. It's the universe's oldest habit, whether in the hands of a Mayan jeweler or the heart of a star. The next time you hold a piece of jade or glimpse gold catching the light, remember, you're not just seeing beauty, you're witnessing the same alchemy that shapes every atom in your body, a dance of energy and form as old as time itself. The Maya envisioned the universe not as empty void, but as a vast, dark sea, and floating upon its waters lay a cosmic crocodile, its armored back forming the very fabric of reality. This wasn't just a poetic image, it was a cosmological blueprint. Each of the creature's scales, glistening like obsidian in the starlight, represented a distinct unit of space-time, interlocking to create the structure we perceive as existence. Modern physics might describe space-time as a flexible grid warped by gravity, but the Maya encoded this truth in myth. Their crocodile's body was the substrate, the living foundation upon which all else unfolded, a startling parallel to how the Higgs field underlies the quantum vacuum, an invisible lattice giving particles their substance. Dive deeper into the symbolism and the parallels grow more vivid. The crocodile wasn't passive, it thrashed its tail during eclipses, rippling the waters of creation. This mirrors the way gravitational waves, predicted by Einstein and observed millennia later, distort spacetime itself. Even the creature's habitat, the primordial sea, aligns with quantum field theory's description of the vacuum as a seething foam of potential. To the Maya, the cosmic crocodile didn't merely inhabit these waters, it was the waters, just as the Higgs field isn't separate from space but woven into its very fabric. The crocodile's scales hold another clue. Mayan artists depicted them as geometric patterns, often hexagonal or diamond-shaped, evoking the pixel-like units of space-time in theoretical physics. Some scholars argue these designs weren't arbitrary but reflected an intuitive grasp of tessellation, the way discrete components could merge into a seamless whole. Compare this to modern spin networks in loop quantum gravity, where spacetime emerges from tiny, interconnected nodes. The crocodile's scales, then, weren't just decoration. They were a mythic precursor to the idea that reality is quantized, built from indivisible building blocks. Rituals reinforced this connection. Shamans donned crocodile masks during solstice ceremonies, their movements mimicking the creature's undulations to stir cosmic energies. Similarly, particle colliders like the LHC agitate the Higgs field, revealing its properties through controlled disturbances. Both acts, one symbolic, one scientific, aim to probe the hidden architecture of existence. Even the crocodile's role as a boundary guardian resonates. Its body marked the edge between the watery abyss and the ordered world, much like the Higgs field demarcates the transition from chaotic energy to stable matter. Perhaps the most profound parallel lies in the crocodile's duality. It was both creator and destroyer. Its jaws could snap civilizations into oblivion, yet its spine upheld the heavens. The Higgs field embodies a similar tension. It grants mass, enabling structure and life, but its interactions also require immense energy to overcome, a barrier fueling the universe's dynamism. The Maya didn't shy from this paradox. They revered it, carving crocodile motifs into temple lintels where they straddled thresholds between realms. So was the cosmic crocodile mere myth, or did the Maya glimpse a truth we've since quantified? The answer might lie in the creature's very name. In classic Mayan, the word emix, often associated with the crocodile, also means world tree, linking it to the axis of creation. This linguistic thread ties the crocodile's sprawling body to the scaffolding of spacetime itself, a living lattice where myth and physics intertwine. Whether through sacred art or superconducting magnets, we're chasing the same profound realization. Reality rests on the back of something ancient, patient, and infinitely powerful, a guardian whose scales are the universe's first and final code. When the sun vanished behind the moon's shadow, the Maya didn't see an astronomical coincidence. They witnessed a celestial battle. Their myths depict eclipses as moments when the sun god, Kinish-Ahau, was devoured by a cosmic jaguar or serpent, his light snuffed out until priests and nobles intervened with bloodletting rituals to strengthen him for the fight. These weren't just stories, they were observations of energy in flux, where light and darkness wrestled in a temporary annihilation. Fast forward to CERN underground tunnels, where physicists recreate a different kind of eclipse, protons smashing together at nearly light speed, their energy collapsing into darkness before erupting into new particles. The parallels are staggering. Both traditions frame transformation as a violent, necessary collapse where destruction births revelation. Consider the Dresden Codex's eclipse tables, which track these celestial skirmishes with eerie precision. The Maya predicted eclipses centuries in advance, interpreting them as recurring battles between cosmic forces. Modern particle physics reveals a similar rhythm. When protons collide in the Large Hadron Collider, they don't just shatter, they unleash a microcosm of the universe's first moments, energy condensing into particles like raindrops from a storm. The sun god's struggle against the jaguar mirrors the Higgs field's own dance. Particles gain mass by fighting against the field's grip, their resistance literally shaping reality. Both narratives hinge on the same truth: creation demands confrontation. The imagery grows even richer when you examine the aftermath. After an eclipse, the Maya believed the sun emerged victorious, purified by its trial. At CERN, detectors capture the Higgs Boson's decay products, fleeting traces of a particle that existed for less than a billionth of a second, yet confirms a cosmic symmetry. In both cases, the clash isn't the end but a doorway. The sun god's rebirth parallels the way energy reorganizes itself post-collision, obeying laws older than myth. Even the blood offerings find a twisted echo in particle physics. Just as royal blood was thought to nourish the gods, the energy sacrificed in collisions feeds the creation of new matter, a transaction written into the universe's ledger. What's most compelling is how both systems grapple with invisibility. The Maya couldn't see the moon's shadow creeping toward the sun until it was too late. Physicists can't observe the Higgs boson directly, only its aftermath. Both developed workarounds, the Maya with ritual, CERN with algorithms to decode what the naked eye couldn't grasp. It's as if eclipses and particle collisions are two dialects of the same cosmic language, one spoken in myth, the other in mathematics. The message, though, remains unchanged. Darkness isn't emptiness, it's the crucible where light and matter are forged anew. Deep in the Dresden Codex, tucked between star charts and eclipse tables, lies an unsettling glyph, a sun disk, not golden but black as polished obsidian. The Maya called it Ekchur, the Black Sun, a celestial force that governed the unseen layers of reality. Unlike the life-giving Kinish-Ahau, this dark counterpart was neither worshipped nor feared in traditional terms. It simply was an invisible anchor, a presence felt but never seen, pulling the cosmos into balance. Modern cosmology describes a remarkably similar enigma: dark matter, that mysterious substance weaving through galaxies, its gravity sculpting the universe while eluding direct detection. The parallels are too striking to dismiss. Both the black sun and dark matter operate in the shadows, their influence undeniable yet their essence just beyond our grasp. Consider how the Maya conceptualized this dark star. It wasn't the absence of light but a different kind of radiance, one that didn't illuminate the physical world but instead shaped its hidden architecture. Priests tracked its movements through arcane calculations, believing it governed the underworld of celestial mechanics, much like dark matter's gravitational scaffolding guides the rotation of galaxies. Even today, astronomers observe stars whirling faster at the edges of galaxies than visible mass can explain, as if tugged by some unseen hand. The Maya might have nodded in recognition. Their black sun, too, was a master of invisible tension, its pull felt in the precise timing of solstices and the alignment of sacred temples. The rituals surrounding the black sun add another layer of intrigue. During rare celestial conjunctions, Mayan astronomers performed ceremonies in windowless chambers, their only light coming from smoldering copal resin. In that darkness, they sought visions of the black sun's influence, echoing modern efforts to detect dark matter in underground labs like Snollab, shielded from cosmic interference. Both pursuits hinge on the same premise: to perceive the imperceptible, you must first eliminate the noise of the visible world. The Maya used hallucinogens and sensory deprivation. Physicists used cryogenic detectors and miles of rock. Yet both ventures reveal a shared understanding. The universe's most pivotal forces often hide in plain sight. What's truly mesmerizing is how both systems account for imbalance. The Maya believed the black sun cycles could trigger upheaval, droughts, wars, the collapse of dynasties if its rhythms were ignored. Dark matter, too, dictates cosmic order. Without its gravitational glue, galaxies would fly apart, their stars scattering like beads from a broken necklace. Both concepts frame the invisible not as passive but as active, a dynamic participant in existence. The black sun wasn't a void, it was a counterweight, just as dark matter isn't empty space but a gravitational keystone. Perhaps the most tantalizing clue lies in the glyph itself. The black sun was often depicted with a spiral at its center, a whirlpool sucking in light. Modern simulations of dark matter halos show a similar structure: dense cores with filaments spiraling outward, trapping galaxies in a cosmic web. The Maya may not have had supercomputers, but their art suggests an intuition about how unseen forces sculpt the universe. Whether carved into stone or rendered in particle physics software, the message is the same: darkness isn't the opposite of light. It's the loom on which light is woven. So was the black sun a prescient metaphor for dark matter? The answer might lie in how both traditions confront the limits of perception. The Maya accepted that some truths could only be approached through metaphor and ritual. Physics, for all its equations, still grapples with dark matter's nature. Is it WIMP? Actions, something stranger. Both worldviews remind us that the universe's deepest mysteries refuse to be pinned down. They hover at the edge of understanding, compelling us to look beyond what's visible, to reckon with the possibility that the most powerful forces are the ones we may never fully see. Among the intricate glyphs of the Mayan sacred calendar, each day carried its own spirit, a unique energy signature embodied by animals, elements, and celestial forces. These weren't just astrological symbols, they were cosmic fingerprints mapping the interplay of forces that shaped human destiny. But what if these day signs held a hidden layer of meaning? Modern physics reveals that subatomic particles possess their own signatures too. Quantum spin states that dictate how they interact with the universe's fundamental forces. The parallels are too tantalizing to ignore. Both systems encode behavior in symbolic language, revealing patterns deeper than chance. Take Amix, the crocodile day. Associated with primordial strength and resilience, Amix aligns uncannily with the spin properties of protons particles that refuse to decay, anchoring the atomic nucleus with tenacity. Then there's Ik, the wind day, linked to breathe and invisible currents. Its fluidity mirrors the behavior of electrons, whose spins can flip unpredictably, dancing like gusts through the quantum field. Even Akbal, the darkness day, finds its counterpart in neutrinos particles so elusive they pass through planets like shadows, their spins barely detectable. The Maya didn't just assign traits to days, they may have intuited a cosmic ledger where every entity, from human to quark, had its place in the grand spin of existence. The Tzolk'in calendar's cycles deepen the metaphor. Just as quantum particles can exist in superposition, spinning both clockwise and counterclockwise until measured, Mayan day signs often embodied duality. Chuan, the monkey day, symbolized creativity and chaos, much like the Higgs boson itself, which decays into multiple particle states simultaneously. The calendar's interlocking wheels, where dates repeated in sacred syncopation, mirror the entangled spins of particles separated by vast distances yet instantly responsive to each other's changes. Rituals added another dimension. On Lammat, the star day, shamans invoked Venus's cyclical appearances, aligning ceremonies with its helical rising. This precision mirrors how physicists prepare particle spins in labs, orienting them to reveal hidden properties. The Maya even had glyphs for binding days together, akin to quantum coupling where spins lock into harmony, creating states more stable than their parts. The brilliance of this analogy lies in its refusal to be literal. The Maya weren't secret physicists, but their cosmology, like quantum theory, sought patterns beneath chaos. Whether through day signs or spin states, both traditions whisper the same truth. The universe is a tapestry of dynamic relationships where every thread, no matter how small, twists in resonant rhythm. What would a physicist make of these eerie parallels between ancient myth and modern particle theory? Dr. Elena Rodriguez, a theoretical physicist at CERN, leans forward with cautious fascination. The Maya's cosmological models were astonishingly sophisticated, she admits. When they described swirling energies giving form to the world, they weren't wrong. They just lacked our mathematical vocabulary. Rodriguez points to the Popol Vuh's creation narrative, where gods shape reality from primordial mist as a poetic analog to the Higgs mechanism. Both frameworks describe emergence, how structure crystallizes from chaos. But where we see quantum fields, they saw divine breath. Archaeologist Dr. Javier Morales offers a counterpoint from his decades excavating Mayan sites. We must resist the temptation to project modern physics onto glyphs and pottery, he cautions, brushing dust from a ceramic fragment etched with star symbols. The Maya's genius was observational. Tracking Venus's cycles required incredible precision, but that doesn't mean they intuited quantum vacuum states. Yet even he pauses at artifacts like the Dresden Codex's eclipse tables. Their ability to model celestial mechanics suggests they perceived deeper cosmic patterns, even if framed through ritual. The tension between these perspectives reveals the heart of the debate. Modern science demands empirical verification. The Higgs boson's discovery required petabytes of collision data from the Large Hadron Collider. The Maya's insights emerged from generations of naked eye astronomy and visionary plant rituals. Still, physicist Dr. Priya Chen notes intriguing overlaps. Both traditions recognize that reality has layers. The Maya's three-tiered cosmos underworld, Earth, heavens isn't so different from how we describe energy scales in particle physics. She taps a whiteboard diagram showing quark confinement. Their underworld's shifting illusions could metaphorically represent quantum foam's probabilistic nature. Where do these comparisons hit their limits? Rodriguez is quick to clarify, the Higgs field isn't magic. It's a quantum excitation with specific properties measurable to 15 decimal places. Morales adds cultural context. Mayan astronomy served agricultural and political needs, not abstract theory. Predicting rainy seasons ensured survival, not particle discoveries. Yet both agree on one profound truth: human curiosity transcends time. Whether through pyramid alignments or superconducting magnets, we're all asking the same fundamental questions about existence's fabric. Perhaps the most humbling insight comes from Chen. Science and myth aren't opposites, they're complementary languages. The Maya encoded cosmic truths in stories, we use equations. But both point toward mysteries we're still unraveling. She gestures to a reconstruction of El Castillo's equinox shadow. That serpent wasn't just art, it was a model of cyclical transformation. And isn't that what the Higgs mechanism does? Turns energy into matter, chaos into order. In the end, these parallels remind us that wonder is universal, whether carved in stone or printed in peer-reviewed journals. Of course, not everyone sees these parallels as anything more than fascinating coincidence. Skeptics argue that drawing connections between Mayan cosmology and the Higgs boson is a classic case of pattern seeking, the human brain's tendency to find meaningful links where none exist. After all, the Maya lacked microscopes, particle accelerators, or even the concept of atoms as we know them. To suggest they anticipated modern physics risks veering into romanticized revisionism, projecting today's knowledge onto ancient symbols never meant to carry such weight. And they're not entirely wrong. The Maya weren't physicists, and their myths weren't equations in disguise. Yet dismissing these overlaps outright misses a crucial point. While the Maya certainly didn't predict the Higgs boson in any literal sense, their symbolic language reveals something profound, a shared human intuition about how the universe operates. Take the concept of cyclical time. The Maya's long count calendar and modern loop quantum gravity both grapple with the idea of repetition at cosmic scales, not because one influenced the other, but because both traditions observed the same fundamental rhythms: seasons, celestial motions, the pulse of creation and destruction. When two cultures separated by millennia land on similar metaphors, it's worth asking why. Consider how both systems handle invisibility. The Maya personified unseen forces as gods in dark underworlds. Physics quantifies them as quantum fields or dark matter. These aren't the same, but they stem from the same root and attempt to explain gaps in observation. The Maya's black sun and a physicist's dark matter halo are cultural responses to the same existential itch. What holds the world together when I can't see it? The answers differ, but the impulse doesn't. Even the skeptic's strongest argument that these connections are arbitrary holds a twist. Yes, the Maya's feathered serpent Kukulkan wasn't a literal particle. But symbolism has power. Myths encode intuitive truths about energy, balance, and transformation, concepts physics now formalizes. When a Mayan priest traced the path of Venus, he wasn't calculating orbital mechanics. He was participating in a story about order emerging from chaos. Isn't that, in essence, what the Higgs mechanism describes? The middle ground here is where things get interesting. Instead of asking whether the Maya knew about the Higgs boson, we might ask how their metaphors, forged without modern tools, still managed to brush against universal truths. Indigenous traditions worldwide have long described reality as interconnected, dynamic, and layered. Science, in its own way, confirms this. The Maya's brilliance wasn't in predicting specifics, it was in crafting narratives that resonate across disciplines, revealing how deeply our species yearns to map the unseen. That resonance is what keeps researchers from both worlds talking. Physicists like Dr. Marcelo Gleiser have explored how myth and science, though distinct, often circle the same mysteries. Meanwhile, modern Maya scholars stress that their ancestors' knowledge was holistic, blending astronomy, agriculture, and spirituality in ways that defied categorization. Neither approach is inferior, they're complementary lenses. After all, if the Higgs field teaches us anything, it's that reality is richer than what meets the eye or the lab instrument. So while it's fair to critique overreaching claims, it's equally limiting to reduce these parallels to mere chance. The Maya's law might not be a roadmap to particle physics, but it's a testament to humanity's enduring quest to name the unnameable. Whether through glyphs or gamma detectors, that quest binds us ancient stargazers and modern scientists alike in a shared, restless curiosity about the fabric of existence. What if the next great leap in understanding the cosmos doesn't come from a lab alone, but from the intersection of indigenous wisdom and quantum theory? The Maya's cosmological insights woven through myth, astronomy, and ritual offer more than historical intrigue. They hint at a radical possibility that blending ancient and modern perspectives could reshape how we approach scientific discovery. Imagine a research paradigm where particle physicists collaborate with indigenous knowledge keepers, not to validate one system with the other, but to ask fresh questions neither could conceive alone. The implications stretch far beyond academic curiosity. They challenge us to rethink humanity's role in a universe that's far stranger and more interconnected than we've dared to believe. Consider the ethical dimensions first. Modern science often treats the natural world as a puzzle to be solved, a machine to be reverse-engineered. The Maya, by contrast, saw the cosmos as a living, breathing entity demanding reciprocity. Their rituals, from bloodletting to celestial alignments, were acts of dialogue with the universe, not domination. As we grapple with climate collapse and the ethical dilemmas of AI, this shift in perspective could be transformative. What if our particle colliders and space telescopes were complemented by ceremonies acknowledging the sacredness of the unseen? It's not about abandoning empiricism, but enriching it, recognizing that data alone can't answer why the universe exists, only how it functions. Then there's the practical potential. The Maya's long count calendar, with its precision across millennia, emerged from observing cyclical patterns invisible to the untrained eye. Similarly, indigenous tracking methods have outperformed satellite technology in predicting animal migrations. Could their holistic approach to pattern recognition, blending empirical observation with symbolic thinking, help physicists decode anomalies in quantum data? CERN algorithms sift through billions of collision events for statistical aberrations. Perhaps a Maya-informed model, attuned to cyclical resonances, might spot overlooked correlations. After all, their astronomers detected Venus's 8-year cycle without telescopes, a feat of computational ingenuity that still astonishes. The most profound implication lies in cosmology itself. The Maya's vision of a layered, animate universe where gods, humans, and stars participated in a shared dance resonates oddly with cutting-edge theories like panpsychism or the holographic principle. Both suggest consciousness and reality are far more entangled than classical physics admits. Indigenous cosmologies often describe spacetime as a web of relationships rather than a void dotted with objects. This isn't mysticism, it's a framework that could inspire new mathematical formalisms. Already, researchers are exploring how quantum entanglement might mirror the interconnectedness described in oral traditions. The Maya's cosmic crocodile, its scales tessellating reality, isn't so distant from spin network models in loop quantum gravity, but blending these worlds demands humility. Too often, indigenous knowledge is mined for metaphors while its custodians are excluded from the conversation. True collaboration means centering indigenous voices in shaping research agendas, not as footnotes but as co-architects. The Maya's descendants, from Guatemala's highlands to Mexico's Yucatan, aren't relics of the past, they're living thinkers whose traditions evolve. Initiatives like the Maya Astronomy Project, where astrophysicists work with local communities to preserve celestial lore, offer a blueprint. When Western scientists listen deeply, they might discover that the ancient and the cutting edge have been asking the same questions all along. Perhaps the ultimate lesson is this: the universe refuses to be split into neat categories. The Maya's glyphs and CERN detectors are both maps to the same uncharted territory. Whether through myth or mathematics, we're all trying to decipher whispers from the dark, signals from the black sun, echoes of the Big Bang, the hum of a Higgs field. The future of discovery might depend on our willingness to stand at the crossroads, where the sacred and the empirical meet, and dare to see the cosmos through both lenses at once. So where does this leave us, with ancient myths as quaint stories, or as untapped reservoirs of cosmic insight? The parallels we've uncovered between Mayan lore and modern particle physics aren't mere coincidences. They're evidence of humanity's relentless drive to make sense of the universe, whether through hieroglyphs or Higgs bosons. The Mayans didn't have particle accelerators, yet their feathered serpents, whirlwind gods, and cyclical calendars mapped patterns we're only now quantifying with equations. Their cosmic crocodile, its scales tessellating reality, isn't so different from our quantum foam. Their hero twin's resurrection mirrors the Higgs mechanism's dance of annihilation and rebirth. Even their concept of zero, a void humming with potential echoes, the quantum vacuum's seething energy. This isn't about claiming the Maya had secret scientific knowledge. It's about recognizing that myth and science are two languages describing the same reality. Where physicists see fields and forces, the Maya saw gods and spirits, but both frameworks grapple with the same fundamental questions: what holds the world together? Why does matter have substance? How does chaos become order? Dismissing their cosmology as primitive misses the point. Their observations of Venus's cycles were as precise as any modern telescopes. Their pyramids were celestial calculators, their rituals controlled experiments in cosmic reciprocity. They may not have known why the universe worked as it did, but their metaphors often circled startlingly close to truths we've since branded as discoveries. The real lesson here is humility. For centuries, Western science dismissed indigenous knowledge as superstition, only to rediscover its insights centuries later. Like the way Mayan agroforestry techniques are now hailed as climate solutions, or how their astronomical precision still stuns researchers. What other wisdom lies buried in oral traditions, waiting for us to develop the tools or the openness to understand it? The boundaries between science and spirituality have always been more porous than we admit. Einstein himself spoke of cosmic religion, a awe for the universe's harmony that transcends dogma. The Maya, too, sought harmony, not in labs, but in rituals aligning human action with celestial rhythms. This isn't a call to abandon empiricism for mysticism. It's an invitation to expand how we define valid ways of knowing. Imagine a science that doesn't just plunder indigenous knowledge for metaphors, but collaborates with its keepers, not to prove their truths, but to ask new questions together. What if Mayan cyclical time could inspire fresh models of quantum gravity? Could their concept of ik, the breath of life, inform theories about dark energy? The answers might surprise us, so as we close this journey, consider this: the next time you hear an ancient myth, listen closely. Beneath the allegory might lie a whisper of something deeper, a shared human intuition about the fabric of reality waiting to be decoded. Whether you're drawn to particle physics or sacred stories, remember, the universe doesn't care what language we use to describe it. It simply is. And the more lenses we bring to bear, equations and epics, colliders and calendars, the clearer our vision becomes. The Maya looked to the stars and saw a living cosmos. We peer through microscopes and find quantum fields. Maybe, just maybe, we're both seeing different facets of the same dazzling truth. Your turn now. Dive deeper, question boundaries, and above all, stay curious. The greatest discoveries often begin where science and wonder meet.